This video is an introduction to the Shopbot CNC router located in STEAMSHOP at Robertshaw. The Shopbot has a 4-foot by 8-foot work surface and can be used to shape and cut wood, plastics, foam, or soft metals like aluminum. The long side of the machine is the x-axis, the short side is the y-axis, and the spindle on the gantry is the z. In this video, we're going to perform 2.5-axis operations, meaning the tool will work across the XY axis and the Z axis will move in incremental steps, all programmed by the user. We'll be using Aspire software to prep our file for the Shopbot. Open Aspire and click Create New File. Aspire's CAD functions are on the left side of the screen and the CAM functions will be on the right. Start with the Job Setup tab on the left. For job type, select single-sided. In job size, enter the dimensions of your material. Confirm that you're working in inches. For the Z0 position, choose Material Surface. For the XY datum position, choose the center. For modeling resolution, just keep the standard selection, and when you're done, click OK. Now the Drawing tab is active. We're going to work from a JPEG file, so click on the Clip Art tab at the bottom. Go to the Local Files tab, select your file location, and choose your file. Double-click to populate the image onto the material. Next, go to the Drawing tab. Under Create Vectors, choose the Trace Vectors icon. Select black and white, preview the design, click Apply, and then click Close. You can click on your design to select it, and you can drag the handles to scale it if you would like to. Right now, all the geometry is grouped together. If you click on it, everything will be selected. We need to ungroup the vectors in order to specify specific operations. Go to Edit Objects, click the Ungroup icon, and now you can edit your design as necessary. You can select individual parts of geometry and delete them if needed. Now we're done with the CAD part of this process, and we're going to start on the CAM operations. Click on the Toolpaths tab on the top right and click the thumbtack pin so it stays on the screen. Here we can see all the options for toolpath operations. If you hover over an icon, it will name the operation. A few common ones are pocketing, profiling, roughing, and finishing. We're going to begin with a pocketing operation, so we'll choose the pocket icon, and then we need to select the geometry for this operation. So click on the geometry you'd like to pocket, and if there's more than one part of geometry, hold Shift while you click, and you can select more than one object at a time. Start on the top right to select your settings. First, we'll set the cut depth of our pocket. Then we need to select the tool, the bit that we're going to be using. We want to click Edit to see the tool settings. You can confirm that the settings will work for your project and change them if necessary. Consult the chart to see recommended settings for feeds and speeds. We're going to be using a 25% step-over rate and 12,000 RPM spindle speed. The feed units should be inches per second. When everything looks good, press OK. We're going to use the suggested settings for the rest of this operation. We need to name the operation, and this should be a name that you'll recognize in the list of operations. Then you'll click Calculate. This is going to show you a preview of the toolpath. If everything looks correct, click Close. Now we'll start on our second operation. We're going to pocket again in another part of the design to a shallower depth. So we're going to select our geometry and follow the same steps that we just took in the last operation. We're going to be using the same bit for this operation, so the only difference is going to be our cutting depth. When you're done entering your settings, again hit Calculate, and it's going to show you a preview of the toolpath. You can look at this in the 3D or the 2D view and just verify that everything looks correct. If everything looks good, press Close. Now we're ready for our third operation. We're going to cut out the outline. This is called profiling. Click the profiling icon and select your outline geometry. Again, enter your cut depth and then choose your tool. So again, go into Edit Tool and make any edits that are necessary. Verify your speeds and feeds and all of your other settings. And when it looks good, press OK. Under Machine Vectors, we want to select Outside for this design. We need to add tabs to ensure that the piece doesn't move when the final pass of the outline is cut. Under the Tab heading, enter the length and thickness of your tabs. Click on Edit Tabs to specify the number and distance of tabs, and you might choose to avoid the corners. Make sure you click Add Tabs. You'll see a preview of the tabs. You can select and delete these or move them as necessary. When you're happy with how the tabs look, click Close. Again, you'll want to name your operation, name it something you're going to recognize, and then click Calculate. Confirm that your profile toolpath looks correct, and if so, press Close. Next, click on the Save Toolpath icon. Select the Shopbot TC Inch as the post-processor from the drop-down menu. Highlight the toolpaths you wish to save and follow the prompts to save to the PC or another location like OneDrive. Operations using the same bit, such as the two pocketing operations that we're doing, can be saved together, but anytime there's a tool change, you're going to need a separate saved file. Now we're ready to use the Shopbot. Fasten your material to the spoil board. If you screw down your material, it is important to make sure that the screws are outside of the toolpath. Load the bit for your first operation into the spindle. Place the collet inside the collar and hand tighten to the spindle. Then insert your bit into the collet and use the wrenches to tighten the bit all the way. There's a key attached to the spindle wrench. Put that in the machine, turn, then turn the red switch and you'll hear a fan turn on. Then go to the corded control box and press the reset button. Open the Shopbot icon on the PC. Click the yellow control icon. In the pop-up, use the arrows to move the gantry. Align the bit into the center of your material. This will be XY00. Click the 0 axes button, select the X and the Y, and click 0. Now we're going to set the Z to 0 on the surface of our material with the Shopbot's aluminum plate. Place the plate under the bit and attach the alligator clip to the metal collar. On the PC, click the Set 0 icon. A pop-up window will ask if you're ready. Press Enter. An alarm will sound, and the bit will move down and touch the plate twice. Now the Z-axis is zeroed. Put away the aluminum plate and alligator clip. Another pop-up window will ask you if you've remembered to remove the aluminum plate. Put on eye and ear protection and turn on the dust collection unit. Turn on the spindle at the control box. Press low RE, then press the green button. On the PC, click Cut Part, choose your file, and press Start. A few more pop-up windows will appear to ask if you remembered to turn on the spindle and if you remembered to zero the Z-axis. Be extra alert when you first start the machine so that you can press the stop button if you've done something wrong. The Shopbot will begin your operation using the settings you provided. If you need to pause the machine, press the space bar. In this demo, I sent both pocketing operations to the machine. It's finishing the first pocketing operation now, and it's going to immediately go on to the next pocketing operation. When all the pocketing is complete, I need to turn off the spindle, and then I'll need to change my bit. Because this is a new tool, I'm also going to need to re-zero the Z-axis. Once I've done both of these things, I can repeat the earlier steps of turning on the spindle, choosing my profiling operation file on the PC, and pressing Start. The finished piece is held together right now with the tabs that we created. I need to unscrew the fasteners and take this off, and then I can remove the tabs, and I have a finished product.